Welcome to this 17th lecture. Here we will see the scattering parameter of two very important microwave device. One is coupler, another is magic T. Now, what is importance of coupler? If you want to couple power from one part to another part, you will use coupler, but there are also other uses that will come at the last part of this, that basically the modern microwave measurement which depends on network analyzer. So, there this coupler is very fundamental device. Similarly, magic T, its property, why it is magic we will understand, there is nothing magical about it, it is well understood, but the thing is magic T is very important part in another very important modern day microwave instrument, that is radar. So, that is why we have selected these two, that network analyzer which is a measurement device, radar which is an useful device for detecting any object, it is a microwave sensor. So, anything, any object you can detect by radar at a large distance which eye cannot see, still radar can see. So, it is one of the fundamental part of those radar. So, that is why we will see the scattering parameter based description of coupler and magic T. Now, first see that when we in a circuits we need to either divide the power. Suppose I am having a main power line, from that I want distribution of power lines, as you see in your day to day activities, that low frequency power, the electrical power, that gets divided into various branches. Similarly, at high frequency also I have suppose a source of power, then from that I want to distribute power. So, that is called power divider. Similarly, if there are several powers are coming, I need to sometimes combine the power. So, power divider or combiner, whatever the thing, the point is you require at least 3 port in this device. So, these are no more 2 port devices as you are seeing till now. So, there will be at least 3 ports. For power division, you can see you require at least 1 port where the input will come, and that will get divided at least in 2, if not more. So, at least 3 ports are required. So, in case of power division, let us say P1 is coming here, and then at output port some P2 and another P3 is coming. Now, if it is a lossless one, I will require that P2 plus P3 is equal to P1, that has been done here, but always this division may not be lossless. In that case, there will be some loss inside the device also. So, this is the lossless power divider. Similarly, for power combining, we require 2 inputs, 2 ports in the input side, and that will give us output. Again, this is the lossless case, but if you do not have this, then this relationship will not hold. There will be also some additional power that is lost here. So, 3 port microwave circuit, that is now we will see. Now, obviously, we will want that it is always desired to have a lossless power divider or power combiner. So, we want the microwave circuit to be lossless, so that no power loss inside the device. Similarly, we also want that the impedance at the ports should be matched. We have discussed in detail the need of impedance matching, otherwise there is power is lost in the mismatch. So, we want that at all the ports the device should be matched to avoid power loss in reflection. Also, there is a need that these devices, if they are made of passive and isotropic material, then their weight is less, because in many of these modern days application, these microwave devices, they need to be microwave electronic circuitry, they are day by day they are becoming miniaturized, they are becoming lightweight. So, for that it is better that the non isotropic material like ferrites etc., they are not used. It is passive isotropic device. If it is, then it is very easy to go for planar technology. So, for going to planar technology, if you have a non-isotropic material like ferrite, it is not amenable to planar technology. So, that is why we also want that the device should be passive isotropic, and that is why the demand is in terms of the device terminology, we want that it should be a reciprocal device. So, that means we demand from a 3-port microwave device, our wish list, that it should be lossless, it should be matched at all the ports, and it should be reciprocal. Now, unfortunately, it can be shown mathematically, I am not going into that mathematics, but unfortunately that is not possible. It is impossible. It can be shown that you cannot have all your 3 wishes from a 3-port microwave network. You can relax any of them, you get. Suppose you can relax a lossless thing. So, you have lossy device, that means you can use resistors etc., then there will be some high amount of loss inside the device, but that can give you power division, power combining, that you can have. Also, you can have that there will be some mismatch, and in that case you can have a lossless and reciprocal device. Similarly, you can also have non-reciprocal device, but lossless and matched. One example of that is circulator, which is heavily used for in case of any microwave transmitter, high power transmitter, and if the receiver is also at the same place. One example is radar, that, or another example is a satellite transmitter and receiver. Now, in that case, when the transmitter is sending power for a radar, suppose a transmitter is sending high power. Now, receivers, they are generally will detect that signal which will be coming from a long distance reflected. So, that is a weak signal, that is why receivers are very sensitive, very weak signal they can detect. But when the transmitter is transmitting, if receiver gets that power, then receiver will be destroyed, because transmitter is sending high power, receiver is detecting very low power. Now, that time you need to isolate the transmitter and receiver. That isolator is generally it is 3-port, because in one of the port the transmitter is put, another port receiver is put, another port the device through which power goes or comes, that is antenna, that is put. So, that 3-port there should be isolation between 2 of the ports when it is transmitting or receiving. That device is called circulator, that is made generally of this non-isotropic material called ferrite, but that is very bulky. That is why nowadays people are trying to find out how to make in the low weight those things, but in 3-port this is one impossibility. That is why, as I have already a slide for circulator, that it is a 3-port, it is lossless, matched at all ports, made of anisotropic material like ferrite, but the problem is it is very bulky. So, it increases the weight of the whole system. So, also there are resistive divider, as I said, that in that case you are suffering loss, but it is matched at all ports made of isotropic material. The disadvantage is you have high insertion loss. Instead of 3-port, if we have 4-port, that thing is will show that it is called directional coupler. It has 4-port, it is lossless, it is matched at all ports, made of passive isotropic material. So, it is reciprocal. So, instead of 3-port, if we open up another port, obviously that means we are having more electronic circuitry. So, 4-port, but if we have 4-port, we have our wish list completed, that we have those 3 properties that we demanded from a microwave network, that it lossless, matched at all port, no mismatch, and reciprocal, all are satisfied. So, that is why directional coupler or couplers are very good, that they are since they satisfy all our wish list, they are used heavily in microwave circuits. This is the one in our lab. We have this directional coupler. This is waveguide based directional coupler. You can also have planar directional couplers or coaxial directional couplers, but this we used. This thing is heavily used if you want to have any antenna radiating and you want to find out how much power it is sending. This is a device without which you cannot find that. So, this directional coupler you see, it has 4 ports. Now, out of that you can see here that the main power is fed in here, port 1. This is port 2 from which that power goes. So, there is a main line here, the lower, you see there are 2 waveguides, one is top, another is here. So, port 1 and 2 is in the main line, we call it main line thing or main waveguide. This is an auxiliary line, you have port 3. Now, actually port 4 is there, but port 4 generally in many applications this is inaccessible to the user. So, sometimes it is used, sometimes not. So, this is a actually 3 port directional coupler. It has 4 port, but we should not call it a port, because unless and until outsiders can access the electronics of that port, you cannot call it a port. So, we have, but to show you we have called it a port. Actually it is not a port, because no power can come out or can be given from here, though power is coming at this end, but it is not accessible outside, that is why it is not a port. But to show you that there was, you can remove this and make it a, if we will put these flanges, you can make it a port here. Okay. Now, let us find what is the scattering parameter of this directional coupler. You see, first we said it is matched at all ports. That means, the S11, S22, S33, S44, they should be 0, because match means there is no mismatch. So, no reflections at the ports. So, that is why in the 4 port we have put the 4 zeros, others we still do not know. So, matched at all ports give us 4 elements of the S matrix, they go to 0. Next, we see we know directional coupler is reciprocal. Reciprocal means we have already found that if the network is reciprocal, its S matrix should be symmetric. So, we have taken that symmetry, we have enforced, that means this parameter S12 and S21, they are same. Now, we could have named them S12 both, we have taken S21 both, because that gives us better insight, that because S21 means when power is given to port 1, how much it is going to port 2. So, instead of S12 we have taken S21. Similarly, S31, S31, S32, S32, S42, S42, then S41, S41, S34, S34. Okay. So, if you count that you have 6 unknowns here, after invoking the symmetric property, you are having how many unknowns? S21 is an unknown, S31 is an unknown, S41 is an unknown, S32 is an unknown, S42 is an unknown, and S34 is an unknown. So, 6 unknowns are there in the S matrix. So, for directional coupler we have invoked 2 properties, one is matched at all ports, another is symmetric, that gives us a 16 element matrix. 4 by 4 matrix means 16 elements, out of that 10 we have eliminated. So, it has now 6 unknowns. Let us see, invoke the another property, that directional coupler is lossless, that is the third wish list we have. So, S should be unitary, and let us further simplify the S matrix. So, S unitary means we can have the one column conjugate with another column, that will be 0. Now, this choice is arbitrary. So, let us start that column 1 conjugate dot column 2, sorry, column 1 conjugate dot column 2, that will be 0, not this one. So, you correct, there is a extra conjugate came, the correct one will be column 1 this extra star won't be there, please correct it. So, and column 3 dot column 3 star, that means column 3 conjugate dot column 4 is 0. That is why we have defined it. You can take any other various choices. We just to illustration sake we have this. Now, we have two equations. Now, you see that if I want to simplify this equation. So, these first two terms if I want to eliminate, you see that I need to multiply by S 41 the first equation and multiply by S 32 the second equation, and then subtraction. So, by that I get this formula that I am calling A. So, this is one formula. So, unitary property means there will be various such conditions, various columns, all there with other column, if it is a conjugate it is 0, with its self conjugation gives you 1. So, various equations will forming. So, this is the first one. Then we have earlier we have column 1 with column 2, now column 1 with column 3, column 1 conjugate with column 3 0 and column 2 conjugate with column 4 0. Again we have shown what to do. So, you get this formula, it is we are calling equation B. Then those two formulas that we got A and B, if you note that there are various solutions of that possible. Out of that we are taking one solution, that S 41 and S 32 are 0. S 41 and S 32 are 0. What is S 41? S 41 means I have given power at input port 1, how much is coming out of port 4. So, that is 0. That means, if I give power at port 1, at fourth port no power will come. Similarly, if I give power at port 2, at third port no power will come. So, those are 0. So, now we put it into the S parameter. So, you see two of those unknowns due to unitary property they have gone. So, we are remaining with 4 complex unknowns, but we have not exhausted unitary property. We will try to further simplify, but out of 6 unknowns, invocation of some of the unitary properties has led to 4 unknowns, but remember they are actually 4 complex numbers, because S parameters are complex numbers. So, basically we have 8 unknowns, because each complex number means an A plus JB, A, B both are real. So, one complex number means 2 real numbers. So, if I have 4 complex unknowns, basically I need to find 8 real numbers to find or determine the S matrix. So, till now we are here. Then we invoke further those earlier one were 2 different columns, their one of their conjugate, that was 0. Now, another property is self a thing. So, by that you can whatever matrix you got from here, I can say S 21 square plus S 31 square is equal to 1, S 21 square plus S 42 square magnitude is equal to 1, this plus this square plus this square 1, this magnitude plus square plus this magnitude square 1. So, 4 such equation. Out of that we have written only 2, and that has done that this 2 says S 31 and S 42 they should be equal. Now, we invoke another property, that means the third row's thing, that gives us that S21 and S34 they are. So, from this we see the guidelines about the magnitude part of the thing. So, a complex number can also be written instead of A plus JB form, which is called rectangular form, it can also be expressed as a magnitude phase form. So, you see that here about magnitude something are seen. So, finally, from here we have got 6 real unknowns. What are they? That S31, S42, S21, S34. You see here that from these 4 complex unknowns, 1 we are removing, and finally, we are having 6 real unknowns. Out of 8, what I said, you have now 6 real unknowns you need to determine. Now, this is your choice. So, generally this choice is made that S21 and S34, though they are complex, we take the reference that their phase are 0. So, S21 and S34, you see that S21 means I have given power at port 1, I am taking it at port 2. So, that one we are taking as reference. So, alpha is a real number. S34 means I am giving at power 4, power at port 4, taking at 3, that is totally unconnected with S21, because S21 is giving at power is given at port 1, S34 is power is given at port 4. So, that is why these two we have made alpha, but S31 I cannot choose arbitrarily, because I have taken S21 as alpha, then S31 should have some phase, and also S31 is different from S21. So, S31 I am taking the magnitude is beta, a real quantity, and phase is theta, another real quantity in angle. So, phase, and S42 will be beta, because S31 magnitude and S42 magnitude, S31 magnitude and S42 magnitude they are same. That is why we are taking that both of them are having beta, but their phase is different, e to the power j5. So, now how many unknowns we are remaining? So, alpha, beta 2 real unknowns, and theta, phi 2 real phase things. So, 4 real unknowns remain for finding any S parameter of a directional coupler. Now, for that again we invoke the property column 2, this we have not invoked till now. We have taken 1, 2, 3, 4 etc. Column 2 star column 2 conjugate dot column 3 is equal to 0. If we invoke that, then we get a relationship between the two phases theta plus phi. It turns out that theta plus phi are not independent, their sum should be phi. Now, from here there are two choices, one is called symmetrical coupler, another is called antisymmetrical coupler. In a symmetrical coupler, this equation theta plus phi is equal to pi, that is solved. So, both of them are taken as same phase, theta and phi both are taken half of this phase, that is pi by 2, that is called symmetrical coupler. If we take antisymmetrical coupler, then theta is taken 0 and phi is taken pi. Okay. So, this becomes a directional coupler. You see that whatever we have said, a directional coupler should have this scattering matrix. You see 6 unknowns alpha, beta, 4 unknowns alpha, beta, theta, phi. Okay. Now, it can be symmetric, it can be antisymmetric. Now, this is the symbol of a directional coupler. Directional coupler input is given, you see that input goes to port 2, whatever is given at port 1, it goes to port 2, it also goes to port 3. Let us see here. You see that this column shows you what is given at port 1. Port 1 something is given, nothing is coming out at port 1 because it is matched. Then some power goes to port 2, some goes to port 3, nothing goes to port 4. That is why port 4 of any directional coupler is called isolated port, that even if you give power at port 1, port 2 and 3 get power, but port 4 do not get power. Okay. Similarly, what happens if we give at port 2, power at port 2, you see nothing is coming out from this port 2, power is going to port 1, power is going to port 4, nothing is also coming to 3. So, if you give power at port 2, port 3 is an isolated port. Similarly, if you give power at port 3, then port 2 is isolated, other ports get something. Then port 4, if you give power, then 1 is isolated, but the nomenclature of the ports is in terms of the port 1 thing, because you will have to standardize. So, nomenclature is generally we give power at port 1, that is why fourth port is called isolated port. This second port is the main line, if you remember in the network analyzer, in the directional coupler diagram. So, this is called through port, port 2, and this third port is called couple port, that is why the name coupler. So, you see in the symbol also we give that thing, that this is couple port, this is through port. Sometimes this spelling through also is written THRU as a short, but actually it is through. Also, this is the diagram of network analyzer, the directional coupler, that this symbol also is sometimes used, that you are giving at port 1, you see port 2 it is going, but main thing is it is getting coupled. That means coupling means I had a line, a waveguide or transmission line. Now, another line is here. So, I am giving power here, obviously power will go here, but this is not coupled power, this is through power, because this is the main line, this is meant for taking that power, but the power if that somehow goes here, then that is called coupled power. You can say how it is good, there is no radiation mechanism here, actually the two lines they are kept one over other, and there are some holes at some selected well designed places, by that the power comes. So, that coupling is shown here, that 1 is getting coupled to 3. Similarly, if you give power at 2, it is getting coupled at 4. Now, you can say why I will give power at 2, I am giving at port 1. True, but that power is going to 2, and then if there is a mismatch inside, you have see ports we have made mismatch, but sometimes if the load etcetera, there are some other thing which is not in our hand, because up to this port we have designed, but after that sometimes if some instead of a match load or something, if there is some other load, then it will come back. Now, that will go to port 4, that will not disturb and come to port other ports like port 3 etcetera. So, this directional couplers they get characterized by 4 quantities, 2 are here. Coupling, it is how much power is from your whatever power you are giving at port 1, how much is going to port 3. Its definition is 10 log P1 by P3. You see that, remember it is not P3 by P1, because then the log will be negative, but coupling we want to say suppose 10 dB coupler, that means that out of whatever power I am giving, 1/10 is going to coupled port, that we write as 10 log P1 by P3, and in terms of S31 you can write it that we have chosen S31 to be beta, that is why I have written it as 10-20 log beta in dB. Similarly, there is another quantity directivity. Directivity means that same thing, that in forward direction I am trying to couple power to port 3. You see this diagram, in forward direction I am trying to couple my port 1 power to port 3. If the power is mismatched, it will come from port 2, it will come to port 4. Now, I want to find that this should be high, whatever coupling I am making here, and this should be low, because even if there is a mismatch, that is not desirable. So, that is why that physically is directivity, that how much power is going to 3 divided by 4. So, ideally this should be very high. In terms of S parameters, I have written that they depends on S31 and S41, and in our chosen ones it is beta etc. S41 we have assumed here to be 0. You see S41 is 0, but in real life S41 is not 0. So, that is why that S41 needs to be measured, and for finding directivity you need to know that. Also there is another thing, isolation. As I said, that how good is your isolation, that means S41, though we are saying it to be 0, but in real life it is not 0. So, that is isolation 10 log P1 by P4, and that you needs to measure. Similarly, insertion loss, that we are saying that there is no power going here, but insertion loss means the directional coupler we are assuming to be lossless, but the thing is when we are giving P1, some power is going to other ports, the full power I am not getting at P2. That is because we are having a coupled port, so some power we are deliberately doing. This is not loss, but you can say that if the forward line transmission is going on, there how much power I am not getting. So, you see sometimes as in a radiation we say spreading loss, though there is nothing loss there. Similarly, here also insertion loss is not loss inside, but as a transport device I am not getting that, because some power I am deliberately coupling. So, to get an idea that how much I am not getting, how much I am using for coupling and measurement etc., that is called insertion loss. This is the definition, and you can do that interrelationship between them is the isolation is equal to D plus C, but the relationship is in dB. You can easily exercise that. Now, directivity measures coupler's ability to separate forward and backward waves. As I said that if you go back to this diagram, that you see in this second one it is showing that directivity means how much I am going here and how much here. Now, this is incident wave. So, incident wave is going to port 3, and whatever is reflected at port 2, that is coming here as port 4, and they are getting separated. Till now we have not mentioned this point, but now you see that in actually any waveguide there is some incident power and some reflected power, but with this 4 port device I can separate them, because in the main line whatever incident they are going here, this one is not at all coming here, they are isolated. So, from reflected wave is not coming here, incident is coming here, incident is not coming here. So, port 4 does not have any incident wave. Now, you see port 4 is only having the reflected wave, and port 3 is only having the incident wave, it is not having any reflected wave. So, 3 and 4 they are separating the incident and reflected wave, a very good thing, because though the whole thing is total, but actually in 3 and 4 we are getting separated incident and reflected wave. So, that ability of these to separate these, that is called directivity. Ideal directional coupler these. Now, this is instrument, you see this is the directional coupler. You see I have seen in the coupled port power is getting measured. You see the sensor is connected here, power is being fed from this left side. So, power is given at port 1, 4 port in this one in laboratory we do not use it, but in actual life the directional coupler 4 is also used. In network analyzer inside there are various directional couplers, they use port 4s. Same thing here, the opposite thing here, the coupled port is matched, this is a match termination and I am sending the power here. Now, separation of incident and reflected wave, as I said, incident wave goes to port 3, it is isolated from port 2, reflected wave goes to port 4, it is isolated from port 1. Incident and reflected wave in main line get separated at port 3 and 4. This is the basis of network analysis, basis of scattering parameter measurement by network analyzer. So, that is why it is so important to understand directional couplers. Now, a particular form of directional coupler is called hybrid coupler, where this coupling factor is 3 dB. Coupling factor 3 dB means whatever power I am feeding at port 1, half of that power is going to the coupled port. If you do that, then the alpha and beta, they turns out to be 1 by root 2. So, now this magic T, what we mentioned initially, that also is called rat race, that is basically this hybrid coupler. So, it is alpha and beta both are 1 by root 2, also it is an antisymmetric directional coupler. So, its theta is equal to 0 and pi is equal to pi. So, its S matrix turns out to be this. You can easily find out that from whatever we left for a general directional coupler, if you put the values of alpha, beta and theta and phi, these are the 4 unknowns. So, if you make this choice, then you get a directional coupler like this. Now, what is the beauty of this? You see that if I apply signal at port 1, that means look at this row, what happens? That signal gets divided between port 2 and 3, their phase is also same. So, we have written evenly split into 2 in phase signals between second and third port, fourth port is isolated. Similarly, if signal is applied at port 4, look at this fourth column, the signal is evenly split between 2 and 3 port, but they are opposite phase and no signal is going to port 1. So, port 1 is isolated. That means, I can use it as a power divider if I give signal at either port 1 or port 4. In both the cases, equal power is getting into the 2 ports, it is getting divided into 2 ports. Now, depending on your wish, if you give it at port 1, you can get that the 2 divided powers, they are at equal phase. If you give the power at port 4, they are at opposite phase. So, power division, but 2 types of power division you can get from here. You can also get it as a power combiner. You see the same scattering matrix. Now, I apply signal at port 2 and 3. Now, 2 means this, 3 means this. So, this is a linear circuit. So, you superimpose that. That means, if I give power both at 2 and 3, then signal is coming only at port 1 and port 4. Now, sum these, this is 2, this is 0. That means, at port 1, whatever power I am giving at 2 and 3, their sum I am getting, and at port 4 I am getting 0. That is why you see that I am giving input at 2 and 3, at 1 I am getting sum, at 4 I am getting difference. So, this is very important, because in radars etc., I want to have that to determine the angle precisely, I need to find out that whatever signal I am getting, I need to sum and I need to divide, and that if I divide this sum and divide signal, we get precise angle measurement, that is called monopulse technique. There this rat race is used, and but in our case, why it is called now magic? You see, this is a picture of a magic tree, that I can use this 4-port device either as a power divider or as a power combiner. Remember what we started this lecture with, that we need to sometimes make power division, sometimes make power combiner. generally they are different device, but rat race one device can give you either a power divider or a power combiner. That also, whether you want sum of power or difference of power, whether you have splitting in equal phase or splitting in opposite phase. This is the waveguide version, left side of a directional coupler. It is the two planes, actually two T junctions in two orthogonal planes, that makes it. The fourth port is here, this is the difference port, this is the sum port, and this is the main line. So, you see there are two auxiliary lines here. Similarly, this is a planar version of the same thing. It is like a rat racing, that you are giving power here, it is coming here, etc. That is why it is called rat race. This is the, in our lab we have this power thing. You see students, they have written, because they get sometimes confused. So, which power port is which one. So, you see these two are 2 and 3 port, this one will be 1 port and this is 4 port. This is the difference port, this is the sum port, these two are your two other ports. So, I think that we have seen very two important devices, rat race or magic T and directional coupler, they are S parameter. So, S parameter gives us to understand what is happening in the physics behind it. Now, in terms of total thing, we could not have done that. Total voltage, total current does not give us that inside picture, but the S parameter, which is how the wave is flowing, that gives us that integrate picture. Okay.